Hello everyone, welcome back to the channel. I hope you guys are doing amazing. Welcome to the video 6 on DP series. Today we are starting a new topic of DP. We will be doing DP on grids. So, in this type of problems, we'll start with two questions of Leetcode to get well acquainted with the basic questions that can be asked with reference to DP on grids and general suggestions which I will give to solve these kinds of problem is that try not to the first suggestion will be to try not to use recursion and memoization. Okay, try not to use recursion and memoization here. Okay, try not to use recursion and memoization unless it's very necessary. I will show you in some cases you can use memoization also, but in general try not to use unless it's very necessary. Okay, and another thing is that how should you approach them? uh, Try to think backwards, try to visualize the backwards. Okay, you need to visualize backwards and uh, find a recurrence relation. Okay, find a relation uh, relation in DP transition. Okay, in DP transition in between the squares of the grids. Okay, in these types of questions you will be asked something like you are given on a grid and you need to find the number of ways to number of paths from start to end. So let's say you will be given that a person is on uh, first row and first column of a grid. Okay, and you are maybe given many rows and many columns. So you need to reach the some point, let's say at the end, you need to reach at the end, and you need to find the number of ways the person can go, given that he can go only right and towards the down, so only the right and down he can move. So in how many ways can he reach this point? Okay, so let's try to solve this problem first. Okay, and this is nothing but the unique paths one. Okay, you need to find all the unique paths. So let's try to see the problem statement exactly. So let's say you will be given some m and n. Okay, you will be given values of m and n only, and you are given an m cross n grid, and you need to reach from the cell 0 0 to the cell m minus 1 n minus 1, and you need to find the number of unique paths. Find the number of unique paths. Okay, uh, find the number of unique paths by going only two kinds of movements, only in the downwards or in the rightward. Okay, so you need to perform these two operations only and reach from 0 to m minus 1 cross n minus 1. So do not use there is a very short solution if you already know permutation and combination. Okay, using combinatrix is a very short solution. Okay, do not try to think this, do not try to, we are doing DP, right? So let's try to understand the DP concept using some simple problems. Okay, so if you know a lot about PNC, do not try to like show your skills here because this is a DP problem. Okay, so no need to do any short here. Try to do in O of m into n time complexity only. Okay, so what is the idea behind this? So let me tell you. Let's say yeah, m rows and n columns are there. So let's say there are number of rows is 4 and number of columns is 6. Okay, so how will the grid look like? It will be something like this. Okay, so what you need to do is you are starting from here. You can move only rightward and downward, and you need to reach here. Okay. So how many number of ways is there? So this is nothing but m, and this is nothing but n. Okay. How many number of ways are there? So if you see from the start, you have two choices, 1 and 2. Okay. And from here also you have again two choices, 1 and 2. Let's say you are then here, you again have two choices. So from every point you have two choices till the end. So you can see that in the order of 2 to the power of n, okay, n or m, okay, n or m 2 to the power, you can solve it using recursive for methods, and you can try to memorize it also. But as I told you, do not try to think these recursion or memorization type of things. Do not try to think it. Okay, so what you need to do is that try to do tabulation directly and think from the backwards. Think from the backwards. Okay, so how you will think from the backwards? You will make a DP table. DP table is nothing but the same grid. You initialize everything with zeros, and you try to write paths, and you try to define some DP states. Let's say DP ij denotes number of ways to reach I comma j, number of ways to reach, let's say, something like I comma j from 0 0. Okay, so you want to reach I comma j from 0 0, that's given by dp ij in the grid. Now if you see, if you want to reach the answer, how many ways it is possible? You can reach either from here, okay. So and if you are looking to reach this, you can reach either from this, so if you try to visualize it very clearly, visualize it very clearly, what will you get? Exactly? So you are on this particular cell, okay. You are on this particular cell which is given by the I comma j. You can arrive at this cell from this cell, and from this cell also. So now let's say number of ways you can reach from cell 0 comma 0. Okay, there is some cell 0 comma 0. So this number of ways is you can reach is given also by the TP. So it is nothing but x, let's say. And this is, let's say, from 0 comma 0 you want to reach here, it's y. So if I tell that how many ways can you reach from 0 comma 0 to this using x and y, what will be your answer? It will be x plus y, right? Because you reach to this point and this point, and you reach there, because you cannot go in like this, because if you go forward you have to come backward only, right? And you know the movements which are allowed are only this and this, downwards and rightwards. So only rightwards and downward movements you need to make and reach this point. So what is this x? This x is nothing but the point of this row and column, which is I minus 1 comma j, and this y is nothing but I comma j minus 1. Okay, and this is nothing but the value. Already told you that dpij denotes nothing but the ways to reach ij from 0 comma 0. Okay, from 0 comma 0 you need to reach ij. So can you tell me now what will be the value of dpij? What will be the value of dpij? Can you now tell me? It's very simple now. Dp I minus 1j, which was nothing but x. Okay, and dp ij minus 1. Okay, you can easily understand this. This whole term was nothing but x, and this whole term was nothing but y. The number of ways to reach from 0 to this is given by x and this y, and you add them up to get the dp transition. Okay, now what will be the base cases here? Can you think of the base cases? You think of the grid again. Okay, you have this first row. Again also you have this first column. If I try to tell you that if you are standing here, and how many ways can you reach in this, let's say in this point? So how many ways? Only using only this and this. So you see, you cannot arrive at this position from the top. You have to arrive only through this, because that's out of the grid. And this position also you have to arrive only this, only this. So you see, there is only one path, only one way to reach from this to this. Do you realize it? And there is also only one way to reach this. So if I tell you at any cell, I will pick you any cell of the first row or first column, you will tell me that to reach that you will have only one way. So can't you do this? You just, whenever you initialize the dp table, you fill the whole rows and columns with one. You fill all the rows and columns with one. Then you do is what is simple. You just keep adding. This will be nothing but 1 plus 1, the number of ways to reach this. Okay, the number of ways to reach this is nothing but this and this. The addition of these two, as I told you just now, right? This will keep increasing, and let's say this is nothing but 3. Now what will be the number of ways to reach this and this? Now it's 6. 3 plus 3, and this will be 6 plus 4 10. This will be 10 plus 5 15. So in this way you can just return dp m minus 1 n minus 1. Okay, I hope you understood how the intuition of grid DP looks like. Okay, the intuition of DP on grids is nothing but very simple. It's the easiest of all. I will say it's the easiest of all. You do not need to do any recursion stuffs. You do not need to do any memoization stuffs. You directly write the tabulation method by doing DP. By doing DP, you directly write the tabulation method. Okay, as I told you. So let's solve this problem. So let's solve this problem on Leetcode. You see, we have this exact same problem, unique paths. There's a robot on an M cross N grid. The robot is initially at the top left corner, and you need to move to the bottom right corner. And the limits of M and N are 100. So I will create a DP table. Ideally, it should be of size M and N, but I will not use vector of vectors. You can use something like vector of vectors, but for my safety, I will use this 101. Okay, the syntax is very short, and that's the only reason. There's no specific other reasons. Okay, so dpij, as I told you, dpij denotes number of unique paths from 0, 0 to I, j. Okay, so I will return to reach m minus 1, n minus 1. I will return nothing but dp m minus 1 n minus 1. It's as simple as that. Okay, so now what should I do? I will fill all the m and n with zeros. Okay, with ones. So what should I do now? It's very simple. I will go through this I less than n, I plus plus. Okay, and this is nothing but the second dimension. N is nothing but the second dimension. So I will fill this first row dp of 0, I with 1. As I told you, the number of ways to reach the first row is always 1, right? And what to do for other one? For if I'm iterating till m, I will fill nothing but dp of I, 0, because the second dimension is that. Okay, so a second dimension is the m, so I will fill the second dimension I with m, and I will fill all the zeros and ones. So as I told you, I'm in these two cases, I'm just filling out first row and first column with ones. Okay, and now it's very simple. I start from the row I equal to 1, and then I will go I less than n. Okay, so a little bit of mistakes here. So here I will just go from j also. J equals to 1, j less than n, j plus plus. I have gone from all the way from 1, 1 to all the rows, right? So I will write the DP transition, which is very simple, as I told you, very simple, very easy. dpi j is nothing but dpi minus 1 j plus dpi j minus 1. So it's very simple and very easy also. So you just return this and try to check if it works. Or we have some errors. You see, we have the accepted case. If you try to submit it, I think it will just work fine with 100% runtime and quite a good memory complexity also. So you can do it using permutation combination also, but then the thing comes that what if I introduce some obstacles here? Okay, so the same question, this unique paths 2 is nothing but the exact same question with the obstacles here. Okay, you have a robot at 0, 0. You need to reach the end. The same thing. This time you will be given the whole grid where 0 denotes the empty cell and 1 denotes the obstacle. So what you need to do, there is one obstacle, you need to avoid the obstacle. You cannot step on the obstacle or pass through it also. So you see, you reach this star from this robot using only two ways. So you have only two ways for this, and m and n here also you have 100. So can't you use the exact same method? Probably, but you need to do little bit of changes. So what are these changes that you need to do? So let's see how you should proceed in this problem. So we have now the second problem with us, unique paths 2. In our grid, now we have some obstacles which we need to avoid. So first try to pause the video and think it on your own. How will you manage to draw the DP table, and how will you exactly see that whether there are obstacles or not? How will you avoid the obstacles? So you just try to look at those things on your own first, and then continue watching the video. So you see, you are starting from here, okay? You say that you have only one space to go here. Again, you have one space to go here. What if you have an obstacle here? What if you are having an obstacle here? Okay, so you cannot go ahead, right? If I tell you, I am denoting obstacle by something like this, okay? Something like this. So if you want to go ahead, if I ask you what is the number of ways to reach in this cell, you cannot reach through other paths, right? You cannot reach through this. This was the only way where there is obstacle. So you will say that there are zero ways to reach this path. There are zero ways to reach all the subsequent paths. So till the first obstacle in both rows and columns, there is only one way to reach, and from the obstacle onwards, there are zero ways. So even if you want to reach this cell, you cannot reach it. So you reach it in zero ways, right? You reach it in zero ways. So, and for the remaining things, you can do the same thing, right? You can just add this and this. But what if there is an obstacle in somewhere in the middle? Let's say you are having an obstacle here. So if you are calculating this cell, you are calculating, let's say, this I comma j. If you use the same method, dpij is, you use the same method dpi minus 1j and dpj plus dpji minus 1. Use the exact same method. It will completely work. There is no problem. But this zero obstacle cell, whenever you will encounter a zero obstacle cell, you will just say that you can reach zeros. You can reach in zero ways. So what will happen is there, this I minus 1j, this is nothing but I minus 1j. This term will cancel out as it has a grid, as it has a obstacle in the grid. So it will just cancel out. It will just cancel out. And the only method, the number of ways you can reach to this cell will be the only way from which you can reach I comma j. So from j I minus 1, okay, so j minus 1, I j minus 1, only you can reach through this, okay, if there is no obstacle here, okay. So first of all, there is no obstacle here. If you are getting confused by this symbol, there is no obstacle here. That's why. So if there is an obstacle, place it with zeros. For the first rows and columns, for the first row and first column, place all the subsequent zeros also. And after, for all the non-obstacle cell only, you use this formula dpij. For non-obstacle cell only, for non-obstacle cell only, you use this. And for obstacle cells, just initialize this dpij as 0, so that it helps calculate future values also if something is below obstacle or something. So let's say if you are having some obstacle, let's say here also and here also, in no way you can reach all these cells, right? You can easily understand. You will add up this 0 and this 0 and get 0 ways to reach here. Then again 0, 0 and 0, you will get 0 ways to reach here. Again 0 ways. So all these cells that should be 0 are becoming 0 without any fault, without any fault. So you see, you can use the exact same thing. You can use the exact same thing. So there is no ambiguity or any kind of any doubt, I think. So what you do is simple. But here you need the m and n, right? So here you just take out the m value grid dot size and the n value grid of 0 dot size. The thing which you should take care here is that the first cell, it should not be an obstacle. Otherwise, you just return 0. If just check that if grade of 0, 0 is an obstacle, then you cannot start your path only, right? If your first cell is an obstacle only, you cannot start your path. If it's an obstacle, 1 means obstacle as it's given in the problem. If it's an obstacle, so what you do, you simply return 0 because there are no paths to reach anywhere in the grid. You cannot start your path, so where you will reach. So this is the thing. And now you can initialize the DP in the same manner as I told you. What's the maximum values? M and N are 101 here also. So you take 101 here. And what you can do is very simple. You just go through all the you are first of all going through the columns, n rows, m rows, and n columns. So if you find grid of I, and this is nothing but the column, so 0i, if it's 1, what you do, you have an obstacle, right? So you initialize this dp 0i, so if it's not, I'm telling about free values only. If it's a free value, you do dpi 0i to be 1, okay, to be 1. And if you whenever you first see an obstacle, you just, whatever you first see an obstacle, you just break the loop, because all the further values will be zeros, and by default you min set the dp initially with all zeros, okay? So it sets all the values of the dp to 0. So this code you can just remember. If you want to set it with -1 also for memorization's case, you can do it. But here I want to set everything with 0. And I'm telling that if there is no obstacle, just do for the first row, you just make it 1. And if there is an obstacle, else you just break it. You don't need to do anything else. And for the first column, what to do? For the first column, you got the first row, right? So for the first column, what you can do is very simple. You just do it in this way, I of 0. And if it's again the same logic follows. If you get an obstacle, you just break it out. Otherwise you set it to 1. And now all you do is very simple. You just go from I and j. You just go from 1 comma 1. You just start from 1 comma 1, okay? J less than m, j plus plus. You see that if my grid does not have an obstacle, if my grid of ij is equals to 0, if it does not have an obstacle, what you do is very simple, very easy. You just write the recurrence. dpi minus 1j plus dpi j minus 1. You just write this, and you do not need to take care of the obstacles here, because if the obstacles you have already taken care of, right? If dp is just 1, you need to fill the dpij as 0 only, and dpij is initially 0. All the cells are 0, right? So you do not need to take care of that separately. You don't need to do something like else dpij 0. If you write it, then also it's exactly the same thing, right? So writing this or not writing this does not make it, doesn't matter, okay? So you can just what you can do is just return it dp m minus 1 and n minus 1. So I guess these problems are really simple, dp on grids. If you try to run this and check if there is any error or not, you see you have the accepted case. Let's try to submit it and check if there is any error. You see there is a runtime error. Let's try to check the code where we went wrong. So we have this m and n. We are initializing the values with whenever the grid is 0, we are with 1, and otherwise we are breaking off. We are just breaking off, right? Okay. Grid dot m is, so first dimension is m. Okay, that's true. You are calling here dpij. So see, I messed up the dimensions here. The first dimension was m and the second was n. So you have this. You try to have this now and try to submit it. See if it works or it still have some error. So you see, we have accepted runtime complexity of 100% also, so it's quite fast also. So I guess you now have a good understanding of basic concept about DP on grids. Okay. So DP on grids, I think it was very easy. It's a very simple topic. Okay. So I will do more problems. Okay, more problems and more variations on the next video on this DP on grids on the same topic. Okay. I will do some more problems on maybe 1 to 2 more videos. Okay, so meet you in the next video. I think that was all for this video. So